class, my name is Marcy.
I'm Louis, and today we're going to be talking about the importance of standard deviation.
So did you know that standard deviation is one of the most important things that you can learn in college? Do you have an idea why?
I never really thought about it, but I do know that standard deviation is a measure of variability.
Yeah, the standard deviation is one way of describing how much variability there is in a sample of data. More precisely, it is the average distance of all the data points away from the center of the sample.
What do you mean by the center of the sample, though?
I mean that you need to know the mean or the average of the sample first, because that is the center of your sample. Then you can figure out how spread out the other data points are. That's what variability means. If the average distance is small, that means all the points are clustered near the center.
Oh, I get it. So the standard deviation is large, and that means the points are really spread out.
Exactly.
I never really thought about what the standard deviation meant. I just thought I needed to know how to calculate it. Now that I know it's the average distance from the mean, it helps me understand the formula for standard deviation a little bit better.
Well, what do you mean?
Well, here, take a look at the formula. Here it shows that the distances between each data point and the mean, x minus x bar, are average. See how they are all summed up, and then divided by roughly by the number of data points, n.
Oh yeah, I see that. I guess it makes sense. The mean is the average data point, so we sum up all the data points, but the standard deviation is the average distance, so we sum up all the distances. But wait, it doesn't look exactly like you're dividing by the number of data points. It looks like you're subtracting 1 from n. Why do we do that?
Well, that's sort of a long story. See, this all goes back to the difference between a population and a sample. We really want to know the center and spread of a population, but that data is really hard to collect.
Oh, so is that why we use data from samples? Are we trying to guess what the population might be like based on what the sample is like?
Yeah, that's basically the general idea of information statistics.
But isn't there a problem? What if you get a weird sample, one that doesn't represent the population at all? A sample is not always a perfect reflection of a population, especially if the sample is small.
See, you're right, that's exactly the problem. Whenever we get a sample, we can only estimate what the population is like. This n-1 business is all an estimate to try and get a decent population standard deviation when you only have sample data.
Really? But does that mean that dividing by n-1, that helps us estimate the population standard deviation?
Yeah, exactly.
That's amazing. How's that possible?
Basically, dividing by n-1 gives you a slightly bigger standard deviation than just by dividing just by n.
Yeah, so what? Why would you want a slightly bigger standard deviation?
Well, the standard deviation computed from a sample tends to be smaller than the standard deviation computed from the actual population.
Really? Always smaller?
Yeah, you can even make up a population, take samples, and try yourself. The only exception is when the sample mean happens to be the same as the population mean. You see, we're always trying to calculate the average distance from population mean, because that's the true center of the population data. But unfortunately, we don't know that number either.
So the standard deviation we calculate when the sample mean is too small, right?
Yeah.
So we want to make it slightly larger?
Yes. So we divide the sum of squared deviations by a slightly smaller number to make the estimated variance slightly larger.
And the standard deviation is just the square root of the variance, right?
Yeah.
So since the variance is slightly larger, so is the standard deviation.
With this corrected estimate, the standard deviation is closer to the true population standard deviation. It's not that you magically guessed the population standard deviation, but you did correct your estimate for being systematically too small.
Oh, so it's sort of like when you're shooting a gun and you're always off to your left. If you aim a little more to the right, you're more likely to be correct, right? So you won't necessarily hit the target, but you correct it for your systematic error.
Yeah, that's like it.
So if I know the population's mean and the standard deviation, I don't need to divide by n-1.
Yeah, but in most situations with real data, you don't know the population parameters.
All of this doesn't really answer my main question though. What is the point of even knowing the standard deviation?
Well, I guess I can see that it's nice to know the mean because it's a good representative of the data set. It's a 1-point best prediction of an individual score. But sometimes just knowing the mean isn't good enough.
Yeah, that's true. Just because a class's average test score is 85%, that doesn't mean that a lot of the people got B's. After all, if the scores are all spread out, then maybe a bunch of people got A's and a bunch of people got C's. But if the scores are all bunched together, then it means that a lot of people in the class got B's.
I guess it's pretty useful to know the variability of a set of data, in addition to knowing the average score. Standard deviation is the most widely used measure of variability in data, and it's often reported in the news or in polls as well.
Really? I didn't realize that. I guess if I want to really understand data in the real world, standard deviation can really help me out. I hope I can remember this even after the test so I can really use it in